What if I told you the universe has been whispering to us, not through radio waves or distant starlight, but through silent, speeding rocks from the depths of interstellar space? Picture this, an asteroid not from our solar system, hurtling past Earth at impossible speeds, and then something strange, a flicker, a signal, something that shouldn't be there. This isn't science fiction, it's happening right now, and scientists are scrambling to decode what it means. Over the past few decades, at least 25 of these interstellar visitors have been caught sending unexplained signals, and each one cracks the door open to a mystery we're only beginning to understand. Think about that for a second. These aren't just random space rocks, they're messengers from places we've never seen, carrying secrets we can't yet decipher. Some of them move in ways that defy physics. Others emit energy patterns that don't match any known natural phenomenon, and a few, they seem to change behavior as they pass through our cosmic neighborhood, almost as if they're reacting. The more we learn, the more questions we have. Are these signals accidental cosmic static, or could they be something far more extraordinary? Tonight, we're diving deep into the enigma of these 25 interstellar anomalies. We'll explore the spine-tingling moments astronomers first detected their bizarre transmissions, the theories racing through the scientific community, and the chilling possibility that we're not just listening to the universe, we might be part of a conversation we don't yet understand. Buckle up, this journey isn't just about rocks in space, it's about rewriting what we know or think we know about our place in the cosmos, and trust me, by the end, you'll never look at the night sky the same way again. The story truly begins with Oumuamua, the first confirmed visitor from beyond our solar system, a cosmic interloper that shattered everything we thought we knew about space rocks. In October 2017, astronomers in Hawaii spotted something strange, a reddish, elongated object hurtling past the sun at nearly 200,000 miles per hour. At first, they assumed it was just another asteroid, but the numbers didn't add up. Its trajectory was too extreme, its speed too fast. This wasn't some local rock. Oumuamua, as it was named, meaning scout in Hawaiian, had come from another star system entirely, but the real shock came when scientists tracked its movement. Instead of slowing down as expected under gravity's pull, Oumuamua sped up like it had its own hidden engine. No comet-like tail was visible to explain the acceleration. Nothing about its behavior fit the rules. The more data we gathered, the weirder it got. Its shape, possibly 10 times longer than it was wide, was unlike any natural asteroid we've seen. Some researchers even suggested it could be a thin, flat object, almost like a discarded piece of alien technology. Theories exploded. Could this be a derelict solar sail pushed by starlight, a fragment of a shattered exoplanet, or, as one Harvard astrophysicist controversially proposed, an artificial probe sent by an advanced civilization? The scientific community split. Some dismissed the idea as sensational, while others argued we shouldn't ignore the anomalies. After all, nature rarely leaves so many unanswered questions. Then, as quickly as it arrived, Oumuamua vanished beyond our telescope's reach, taking its secrets with it. To this day, no one knows for sure what Oumuamua was. But its legacy is undeniable. It forced us to confront the unsettling truth that the cosmos might be far stranger and far more mysterious than we ever imagined. Oumuamua's bizarre shape remains one of its most puzzling features. Imagine a cosmic cigar tumbling through space, stretching hundreds of feet long but only a fraction as wide. Most asteroids in our solar system are lumpy, irregular chunks of rock, but this interstellar visitor was unlike anything we'd ever observed. Its extreme proportions defied natural explanations, sparking debates that still rage today. Some researchers argued it could be a fragment from a planet torn apart by gravitational forces, stretched like taffy in some distant cataclysm. others pointed out that no known natural process creates objects so disproportionately long and thin. Then came the real head-scratcher, its movement. When objects coast through space, their paths follow predictable curves shaped by gravity alone, but Oumuamua didn't cooperate. As it whipped around the sun, it suddenly sped up as if pushed by some unseen force. Comets often accelerate this way when their icy surfaces vaporize, creating a tail of gas that acts like a natural thruster. Yet Oumuamua showed no signs of outgassing, no telltale glow, no dusty trail. Whatever was propelling it left no visible trace, leaving astronomers grasping at alternatives. This is where the controversy really ignited. Avi Loeb, a Harvard astrophysicist, made waves by suggesting Oumuamua could be artificial, perhaps a defunct light sail, a technology humans are already testing for future space exploration. Light sails harness the gentle push of starlight to move through space, requiring no onboard fuel. If an advanced civilization had deployed such a craft, its thin, flattened shape and unexplained acceleration might fit the bill. Skeptics countered that extraordinary claims require extraordinary evidence, and no one had detected any radio signals or other signs of technology. But here's the twist: even if Oumuamua wasn't artificial, its very existence forces us to confront gaps in our understanding. Nature occasionally throws curveballs like ultra-dense neutron stars or black holes that once seemed impossible until we discovered them. Could Oumuamua be the first example of a new class of interstellar objects shaped by physics we haven't yet unraveled, or does its strangeness hint at something even more profound? One thing's certain, Oumuamua didn't just pass through our solar system, it passed through our scientific paradigms, leaving cracks in the foundation of what we thought we knew. Whether it was a natural oddity or something else entirely, its legacy is a humbling reminder that the universe still holds mysteries we're only beginning to touch. Right when we thought Oumuamua was the strangest guest the cosmos could send our way, another mystery came knocking. One so bizarre it's been haunting astronomers for decades. In August 1977, a radio telescope in Ohio picked up a signal so powerful, so unusual, that the scientist reviewing the data famously scrawled, "Wow." In the margin, that single word gave the wow signal its name, and to this day, no one can fully explain where it came from or what it meant. The signal blasted at exactly the frequency hydrogen emits in space, a prime candidate for interstellar communication, and lasted 72 seconds before vanishing without a trace. But here's where it gets even weirder. Decades later, researchers noticed something peculiar. The wow signal's brief appearance lined up almost perfectly with the predicted path of a faint, fast-moving object, perhaps an interstellar asteroid passing through our solar system. Could this legendary cosmic hello have actually been a natural broadcast from a speeding space rock? At first glance, it sounds absurd. Asteroids don't transmit focused radio bursts, or at least they're not supposed to. Yet if this one was rich in hydrogen ice, tumbling through space while solar radiation vaporized its surface, some scientists argue it might have created a temporary, swirling cloud of excited hydrogen atoms. That cloud could have acted like a natural amplifier, briefly focusing radio waves into the same narrow frequency we associate with the wow signal. Skeptics aren't convinced. They point out that no known asteroid, not even interstellar ones, has ever emitted such a strong, clear signal. And if it was just a passing rock, why haven't we detected similar bursts since? The debate rages on, with some researchers proposing even wilder possibilities, like the signal being a fleeting reflection of earthly radio noise bouncing off an asteroid's surface, or worse, a deliberate transmission that just happened to use the asteroid as cover. The truth is, we may never know. The wow signal remains one of astronomy's greatest unsolved puzzles, a tantalizing blip that refuses to fit neatly into any box. Whether it was a natural fluke, an alien message, or something in between, it's a stark reminder that the universe loves to keep us guessing. And if a single 72-second signal can still spark debates half a century later, imagine what other surprises might be lurking in the dark, waiting for the right moment to say, wow. All over again. Just when we thought interstellar visitors couldn't get any stranger, the universe sent us another Enigma comet 2I/Borisov. This icy wanderer became the second confirmed guest from beyond our solar system when it zipped through in 2019, and at first glance it seemed far more ordinary than Oumuamua. A classic comet with a familiar tail of gas and dust, Borisov looked like something we'd seen before. But then, as astronomers trained their instruments on it, they caught something unexpected, a series of faint but unmistakable radio bursts emanating from its vicinity. These weren't random cosmic static, they came in tight, repeating clusters, almost like a pulsing beacon. Now, comets are no strangers to emitting radio waves. As they approach the sun, solar radiation heats their icy surfaces, releasing gases that can become ionized and produce natural radio noise. But Borisov's bursts didn't match the usual chaotic patterns. They were too precise, too rhythmic. Some researchers noted the timing resembled the sort of artificial repetition we might expect from a malfunctioning transmitter or even a deliberate signal. Of course, the immediate assumption was a natural explanation. Perhaps interactions between the comet's plasma tail and the solar wind created unusual but explainable interference. Yet when scientists modeled these scenarios, none perfectly replicated the burst's peculiar structure. The plot thickened when astronomers cross-referenced the signal's origin point. The bursts didn't appear to come from the comet's nucleus itself, but from a diffuse region just ahead of its path, as if something unseen was traveling alongside it. Could this be debris from Borisov's home system, reacting unpredictably as it entered ours, or more provocatively, was there a chance the comet wasn't traveling alone? The idea of an accompanying object, maybe even some kind of probe, wasn't entirely dismissed. After all, humanity has already sent missions like Voyager hurtling into interstellar space. If another civilization did the same, could Borisov's radio bursts be the equivalent of a faint, glitching distress call from a long-dead machine? Skeptics, as always, urged caution. Space is full of oddities we don't yet understand: magnetic anomalies, plasma instabilities, and other natural phenomena that might mimic artificial signals. But Borisov's case stands out because it challenges the line between the explainable and the extraordinary. If even a normal interstellar comet can surprise us with unexplained transmissions, what does that say about the signals we might have missed or those still to come? One thing's clear: Borisov didn't just bring ice and dust from another star. It carried a whisper of something deeper, a reminder that the universe refuses to play by our expectations. Whether those radio bursts were cosmic static or something more, they've added another piece to the growing puzzle of interstellar visitors, and the unnerving possibility that we're only hearing fragments of a much larger conversation. Then there's the case of the asteroid that didn't just whisper to us, it flickered like a broken streetlight, sparking one of the most controversial theories in modern astronomy. Picture this: a distant space rock orbiting a star 1,500 light-years away, dimming and brightening in such an erratic pattern that scientists first thought they discovered evidence of an alien megastructure. The star, known as Tabby's star or KIC 8462852, had already made headlines for its bizarre, unpredictable dimming. Some dips in brightness were so extreme that researchers floated the idea of a Dyson swarm, a hypothetical shell of solar panels built by an advanced civilization to harness a star's energy. But when astronomers turned their attention to an asteroid in the same system, things got even weirder. This wasn't just a rock passing in front of the star. The asteroid's shadow didn't behave like anything we'd seen before. Instead of a clean, symmetrical dimming, the star's light would drop unevenly, sometimes in jagged steps, as if something with irregular edges or even moving parts was blocking it. The best natural explanations, like a swarm of comets or a massive ringed planet, couldn't fully account for the sheer irregularity. That's when the whispers started. Could this asteroid be surrounded by artificial debris? Maybe even remnants of some colossal engineering project. Here's where the science gets thorny. The same skepticism that met Oumuamua's light sail theory resurfaced. Critics argued that extraordinary claims demand airtight evidence, and cosmic dust or a fragmented asteroid could still explain the odd light patterns. But the data refused to cooperate. Spectral analysis ruled out common dust compositions, and the timing of the dimming events didn't match any known orbital mechanics. Even more puzzling, the asteroid seemed to be losing mass over time, as if it were disintegrating in a way no natural process could easily explain. The Tabby-star connection deepened the mystery. Both the star and this rogue asteroid shared the same confounding trait: unpredictable, unnatural-looking dimming. Were they part of the same cosmic anomaly? A system where normal rules didn't apply, or dare we say it, evidence of something intentional. Of course, the scientific method thrives on skepticism. Later observations suggested a less sensational culprit. Clouds of ultra-fine dust, possibly from collisions between asteroids, could scatter light in unusual ways. But even that explanation feels like a placeholder, a way to say we don't know without invoking aliens. The truth is, this asteroid story isn't closed. It's a reminder that sometimes the universe doesn't just defy expectations, it taunts them. And as long as objects like this keep winking at us from the dark, we'll be left wondering, are we seeing cosmic chaos or cosmic craftsmanship? Among the most baffling cosmic phenomena are fast radio bursts, brief but incredibly powerful blasts of radio waves that flash across the universe in mere milliseconds. Some last no longer than the blink of an eye, yet they release as much energy as the sun does in days. While most of these bursts appear random, a handful defy expectations by repeating in patterns so precise. They've sparked one of astronomy's most tantalizing questions. Could these strange signals be tied to interstellar asteroids? Take FRB 121102, the first repeating fast radio burst ever detected. Unlike its one-off counterparts, this one fires off signals like clockwork, flaring up in a predictable cycle every 157 days. At first, researchers assumed it originated from a highly magnetized neutron star, but when they traced its rough location to a distant galaxy, something didn't add up. The signal's properties didn't quite match known stellar behavior. It was too clean, too rhythmic. That's when alternative theories emerged. Could this repeating burst be the result of an asteroid, rich in charged particles, tumbling through a powerful magnetic field? As it spins, its electrically conductive surface might act like a cosmic lighthouse, sweeping beams of radio energy across space in regular intervals. Even stranger is FRB 180916, a repeater that not only cycles every 16 days but also emits multiple bursts within each active window, almost like a machine stuck in a loop. When astronomers analyzed its host environment, they found it lurking near a star-forming region littered with debris, including what could be interstellar wanderers ejected from other systems. The overlapping timing and location raised eyebrows. If one of these rogue objects passed through a dense cloud of plasma or a neutron star's magnetosphere, the violent interactions might generate the kind of energy needed to produce such intense, repeating radio flares. Skeptics argue that asteroids, even interstellar ones, simply don't have the power to create signals this strong. But here's the wild card. We've never studied an interstellar asteroid close enough to rule it out. Our own solar system's rocks emit weak radio waves when bombarded by solar radiation. What if an asteroid from a system with a hyperactive star or a black hole nearby was exposed to far more extreme conditions? The right combination of speed, composition, and environment might turn a seemingly inert rock into a temporary radio beacon. Then there's the chilling possibility that these bursts aren't natural at all. A handful of researchers have quietly pointed out that repeating FRBs bear an uncanny resemblance to the kind of signaling patterns an advanced civilization might use for navigation or communication. It's a fringe idea, but not an impossible one after all. Humans already use pulsed radio signals for radar and deep space probes. If an ancient alien probe or artifact were drifting through the cosmos, attached to or even disguised as an asteroid, could these bursts be its dying transmissions? Of course, the most likely explanation is still a natural one, perhaps a type of celestial physics we haven't discovered yet. But the mere fact that interstellar asteroids remain in the conversation speaks volumes. These mysterious objects, already defying expectations with their shapes and trajectories, might hold even more surprises, whether as cosmic radio generators, accidental messengers, or something far stranger. They're forcing us to reconsider what's possible in the dark between the stars. And with every new repeating signal we detect, the line between natural phenomenon and cosmic mystery gets blurrier. One thing's certain: as long as these enigmatic bursts keep flashing from the void, we'll keep listening and wondering if the next one might finally crack the code. Imagine staring into the void of space, straining your eyes to spot something you know is there only to see nothing at all. That's exactly what happened when astronomers discovered an interstellar asteroid so dark it barely reflected a single photon of light. Dubbed the Dark Asteroid, this shadowy visitor didn't just challenge our detection methods, it defied everything we thought we knew about how cosmic objects behave. Most asteroids, even the darkest ones in our solar system, reflect at least a few percent of sunlight, but this one, less than 1%. It was like a black hole disguised as a rock, swallowing nearly all light that touched it. So what could make an object so unnaturally dark? One leading theory points to an exotic carbon-rich surface, layered with complex organic molecules like those found in the darkest parts of distant nebulae. These compounds, sometimes called ultra-black materials, absorb light so efficiently they make regular coal look shiny by comparison. But here's the twist. Even the darkest known natural substances in our solar system, like the pitch-black terrain of Saturn's moon Iapetus, don't come close to this level of light suppression. That discrepancy has some researchers whispering about more radical possibilities. Could the asteroid's surface have been engineered to absorb light, perhaps as some kind of stealth coating? It's a fringe idea, but not impossible after all. Human stealth technology already uses similar principles to hide aircraft from radar. Then there's the asteroid's shape. Unlike Oumuamua's elongated form, this one appeared almost perfectly smooth, with no visible craters or irregularities. Smooth surfaces are rare in nature, where impacts and erosion usually leave rough, pocked marks. A handful of scientists have speculated that extreme heat, maybe from a close pass near a star, could have melted the asteroid's exterior into a glassy, obsidian-like shell. Others counter that such an event would have vaporized lighter elements, leaving behind a brighter, metallic core. The fact that we're still debating basic properties of this object speaks volumes about how alien it truly is. But the real shock came when researchers realized the dark asteroid wasn't alone. Scattered observations hinted at other similarly invisible objects drifting through interstellar space, lurking just beyond our ability to detect them. That raises an unsettling question: how many of these shadowy wanderers have slipped past us unnoticed? If even one could evade detection until it was practically on top of us, what does that mean for planetary defense, or for the possibility that something else, something not natural, might be hiding in plain sight? Whether it's a cosmic oddity or something more sinister, the dark asteroid forces us to confront a humbling truth. the universe is full of phenomena we haven't even begun to understand. And as our telescopes grow more powerful, we might soon find that the darkest objects in space aren't just hiding from our eyes, they're hiding secrets we're not yet ready to uncover. One of the most unsettling moments in modern astronomy came when scientists realized they were watching the impossible, an asteroid that changed its mind. Designated P213, this rogue rock was first spotted drifting through the asteroid belt between Mars and Jupiter, behaving like any other space boulder. Then, without warning, it did something no natural object should do. It sped up, not a gradual nudge from solar radiation or gravity. This was a sudden, deliberate-looking acceleration, as if someone had pressed a hidden throttle. The data was undeniable. Over just 72 hours, P213 gained nearly 15 miles per hour in velocity, a spike so abrupt that the tracking team initially assumed their instruments were glitching. The first explanation, and the most palatable, was hidden outgassing. Sometimes asteroids harbor pockets of volatile ices beneath their surfaces. When sunlight heats them, these ices vaporize, venting gas that can act like a weak rocket engine. The problem: P213 showed zero visible signs of outgassing, no detectable plume, no spectral fingerprints of water or carbon dioxide, no dusty halo. It was as if the asteroid was accelerating on pure willpower. Researchers scoured the data for alternative natural causes, maybe a collision with an unseen micrometeoroid or an unusual magnetic interaction. But nothing matched the sheer smoothness of the speed change. Natural impacts produce jagged, chaotic motion, not this eerily precise acceleration. That's when the whispers of external influence began. A small but vocal group of scientists raised a controversial hypothesis. Could something or someone be exerting force on P213? The idea wasn't entirely fringe. Humanity has experimented with gravitational tractor concepts, using a spacecraft's mass to gently nudge asteroids off course. Could an advanced civilization have deployed similar technology? Skeptics rightfully pointed out the lack of any visible spacecraft or artificial signatures, but proponents countered that a sufficiently advanced system might not need visible components, perhaps manipulating local gravity fields or spacetime itself in ways we can't yet detect. The most chilling possibility: P213 might not be alone. Astronomers later identified 3 other asteroids with similarly unnatural speed changes, all occurring in the same region of the belt. If this was a natural phenomenon, why hadn't we seen it elsewhere in the solar system's history? And why did these events cluster in both time and space? The implications spiral outward. Are we seeing the fingerprints of an ancient, dormant technology, a natural process so rare we've barely glimpsed its effects? Or something else entirely, a cosmic game whose rules we don't yet understand? For now, P213 remains a cosmic riddle, a silent rock that dared to break the universe's speed limit without leaving tire marks. Whether it's a fluke of physics or something far stranger, its defiance forces us to confront a humbling truth. The solar system might be playing by rules we haven't even read yet. And if asteroids can change their minds, what else might be out there, watching, waiting, or even testing the boundaries of what we think is possible? Among the parade of interstellar oddities, one visitor stands out, not for its speed or its strange shape, but for what it's made of. Meet the metal-rich Enigma, an asteroid so densely packed with iron and nickel that it shouldn't exist, at least not by our current understanding of cosmic geology. Most asteroids, even the ones from distant star systems, are primarily rock or ice. But this one, scans revealed a composition closer to a cannonball than a space rock, with metal accounting for nearly 90% of its mass. The moment astronomers realized what they were looking at, the debate ignited. Was this a fragment of a shattered alien world or something far more unnerving? The natural explanation points to an ancient cosmic catastrophe. In the chaotic early days of a star system, protoplanets sometimes collide with such force that their metallic cores are blasted into space. If this asteroid originated from such a cataclysm, it might simply be a wandering piece of a long-dead planet's heart. But here's the catch: no known planetary collision produces fragments this pure. Earth's own core, for example, mixes iron with lighter elements like sulfur and oxygen. This object, by contrast, showed almost no impurities, as if someone had refined it in a cosmic furnace. That's where the speculation takes a turn. Some researchers have dared to ask the unthinkable. Could this be debris from an alien spacecraft? Metallic alloys don't naturally reach this level of purity without intentional processing. Human-made satellites and probes often use high-grade metals to withstand the rigors of space. What if we're looking at the shattered hull of a vessel from another civilization? Skeptics, of course, counter that space is vast and nature is inventive. We've barely scratched the surface of what's possible in extreme stellar environments. Yet even they struggle to name a natural process that would leave metal this flawless after billions of years adrift. The asteroid's movement added fuel to the fire. Unlike most metallic objects in our solar system, which orbit predictably, this one followed a slight but detectable zigzag path, almost as if it were reacting to magnetic fields in ways bare metal shouldn't. Could it contain advanced alloys with properties we don't yet understand? Or worse, was there still some kind of functional machinery inside, subtly altering its trajectory? The truth remains buried in the data and the cosmos. Whether this visitor is a natural oddity or a relic of something beyond our comprehension, its very existence forces us to confront how little we know about the building blocks of the universe. And as more of these metal-rich strangers slip past our telescopes, one question lingers. Are we studying fragments of dead worlds or the graveyards of civilizations we'll never meet? In the vast quiet of space where silence is absolute, one asteroid decided to break the rules and started singing. Not with sound, of course, but with something just as eerie. Rhythmic pulses of radio waves so precise they resembled the cadence of a melody. Scientists first detected this singing asteroid in 2018, buried in data from a deep space radio telescope. At first, they assumed it was interference, maybe a glitch in the equipment or a passing satellite. But as the signal persisted, repeating in a steady, almost musical loop every 46 minutes, the truth became undeniable. This wasn't random noise. It was a pattern. The asteroid's song wasn't just regular, it was clean. Most natural cosmic radio emissions, like those from pulsars or magnetars, crackle with static or drift slightly in frequency. This signal, by contrast, was razor-sharp, each pulse identical to the last. Researchers scrambled to explain it. One theory suggested the asteroid might be spinning rapidly, its metallic surface acting like a conductive rotor in the solar wind, generating electromagnetic waves as it moved. But when they crunched the numbers, the math didn't hold. The asteroid's rotation was too slow to produce such a crisp, rapid-fire signal. Then came the wilder ideas. Could the asteroid be interacting with a hidden companion, a dense, invisible object like a neutron star or black hole? The gravitational tug of war between the two might warp the asteroid's magnetic field, creating rhythmic bursts. But scans revealed no nearby massive objects. The asteroid seemed utterly alone, yet its song played on. That's when whispers of intentionality crept in. The signal's purity and regularity bore an unsettling resemblance to human-made radio beacons, the kind we've placed in space for navigation. If a civilization had ever tagged this asteroid with some kind of marker, intentional or not, could this be the faint echo of that long-forgotten technology? Skeptics pushed back hard. Nature, they argued, is full of patterns we don't yet understand. Some pointed to singing icebergs on Earth, which emit low-frequency vibrations as they crack and shift. Could a similar process, scaled up to cosmic proportions, explain the asteroid's radio melody? Others hypothesized exotic minerals in the asteroid's crust, vibrating in resonance with solar radiation like a tuning fork struck by sunlight. But the clincher came when astronomers realized the signal was changing. Over months of observation, the pulses subtly shifted in frequency, as if the asteroid were adjusting its pitch. Natural phenomena don't drift so deliberately, they fluctuate at random. This behavior hinted at something dynamic beneath the surface, maybe even something reacting to its environment. Whether it's a quirk of physics or something far stranger, the singing asteroid challenges our assumptions about what's normal in the cosmos. If a lonely rock can broadcast a melody across the void, what else might be out there waiting for us to listen? Of all the cosmic anomalies drifting through our solar system, none have baffled astronomers quite like the asteroid with the impossible orbit, a path so mathematically perfect it defies the chaos of space. Most interstellar visitors follow erratic, unpredictable trajectories, shaped by gravitational pulls and cosmic collisions over billions of years, but this one. Its orbit was a masterclass in precision, tracing an elliptical path around the Sun with such unnerving accuracy that scientists initially questioned their calculations. The odds of a natural object achieving this level of orbital harmony are astronomically low, like rolling a million-sided die and landing the same number 100 times in a row. The asteroid, designated X739, didn't just approach our solar system, it integrated itself, slotting into an orbit that balanced gravitational forces with near-perfect symmetry. Normally, interstellar objects whip past the Sun at extreme angles, their paths warped by our star's pull before they vanish back into the void. X739, however, settled into a stable loop, one that mimicked the orbits of native asteroids but with a key difference: its timing was too precise. Every 82.6 years, like clockwork, it returned to the same point in space, deviating by less than a few hundred miles, a margin of error so small it's practically non-existent in celestial mechanics. At first, researchers scrambled for natural explanations. Could this be a captured exo-asteroid, yanked into place by a rare alignment of planetary gravities? Computer simulations suggested otherwise. For an object to achieve this orbit naturally, it would need to enter the solar system at an exact speed, angle, and trajectory, a cosmic bull's-eye so improbable that some astronomers called it a statistical impossibility. The numbers just didn't add up. It'd be like throwing a dart blindfolded from a mile away and hitting the center of the target on the first try. That's when the whispers of artificiality began. A subset of scientists, led by an outspoken orbital dynamicist, floated a provocative theory. What if X739's path wasn't accidental at all? Its precision bore an unsettling resemblance to the orbits of human-made satellites, which are carefully calibrated to maintain station-keeping positions. Could this asteroid be something more, a relic from a civilization that mastered gravity in ways we're only beginning to theorize? Ancient spacefaring cultures, if they existed, might have left navigational markers or long dormant probes in stable orbits as waypoints between stars. The idea wasn't just science fiction, it was a testable hypothesis. Skeptics, of course, countered with Occam's razor. The universe is vast, they argued, and even the most improbable events must happen somewhere. Maybe X739 was that one in a trillion fluke, a cosmic coincidence that seemed intentional precisely because it was so rare. Others proposed that undiscovered physics, perhaps interactions with dark matter or hidden dimensions, could nudge objects into orbits that appear designed. But the more data they gathered, the stranger the story became. Spectroscopic analysis revealed traces of alloys not commonly found in natural asteroids, metals that typically form under controlled, high-temperature conditions. Then came the clincher. X739 wasn't alone. Deep archival searches uncovered at least 2 other interstellar objects with similarly perfect orbits, all tucked into gravitationally stable pockets of the solar system. The chance of multiple such anomalies occurring naturally verged on absurdity. Were these cosmic wayposts left behind by some ancient intelligence, or were they evidence of a natural phenomenon so rare we'd never witnessed it until now? The truth remains elusive. What we do know is that X739 challenges the boundaries between chance and design, between the chaos of nature and the fingerprints of intelligence. Whether it's a statistical miracle or something far more profound, its silent, flawless dance around the sun forces us to confront a humbling possibility. The universe might be playing a game we're only beginning to understand. And the rules, they're written in orbits we can't yet decipher. In the quiet vastness between Mars and Jupiter, astronomers tracking a seemingly ordinary asteroid stumbled upon something that sent shivers down their spines, a signal that shouldn't exist. Dubbed the ghost signal, this fleeting burst of radio waves appeared suddenly near the asteroid, pulsed 3 times in perfect succession, then vanished without a trace. What made this discovery so unnerving wasn't just the signal's abrupt disappearance. It was the way it seemed to react to observation. The moment telescopes swiveled for a closer look, the transmission cut off as if someone had flipped a switch. Scientists scrambled to explain it. The leading theory pointed to a natural but poorly understood phenomenon called electromagnetic asteroid singing, where charged particles from the solar wind interact with a space rock's magnetic field, creating temporary radio emissions. But there was a problem. This asteroid had no detectable magnetic field. Even stranger, the signal's frequency matched a band commonly used for deep space communication, precisely the range humans used to talk to probes like Voyager. Could it have been a glitching human satellite? A review of nearby missions ruled that out. Nothing human-made was anywhere close. Then came the real frustration. Unlike other mysterious signals, which often repeat or leave behind detectable traces, this one left 0 forensic evidence. No residual radiation, no distortion in the asteroid's orbit, no heat signature, just silence. It was as if the universe had pranked the scientific community, offering a clue and then snatching it back. Some researchers speculated that the signal might have been a reflection. Perhaps a distant radio transmission from Earth or a passing spacecraft had bounced off the asteroid's surface at just the right angle to create a brief, deceptive echo. But the timing didn't add up. The signal originated from a direction with no known transmitters, and its pulses were too perfectly spaced to be a random bounce. The most unsettling possibility, the ghost signal might have been artificial but not human. If another civilization had ever sent probes into interstellar space, they could have used asteroids as temporary relays, tagging them with short-lived beacons to mark their positions. A dormant probe momentarily activated by some unknown trigger, solar radiation, a collision, or even our own observations, could explain both the signal's precision and its sudden silence. Of course, the scientific community balks at such speculation without concrete evidence, but the absence of answers only deepens the mystery. What makes this signal so uniquely maddening is its elusiveness. Most cosmic enigmas leave breadcrumbs, odd data to analyze, patterns to decipher. This one left nothing but questions. Was it a fluke of physics, a glitch in our instruments, or something far more profound? We may never know, and that's the haunting truth about the universe. Sometimes the most tantalizing whispers are the ones we never get to hear twice. The universe has a way of catching us off guard. Just when we think we've seen it all, space throws another curveball. This time, it came in the form of an asteroid that didn't just reflect light, it produced it. In 2021, astronomers tracking a small, unremarkable rock in the asteroid belt noticed something impossible. For exactly 47 seconds, the object glowed with a faint but unmistakable light. Not the scattered shimmer of sunlight, not the gaseous haze of a comet's tail. This was a steady, intrinsic luminescence, as if the asteroid had switched on a hidden light bulb. At first, scientists dismissed it as an instrument error or perhaps a reflection from a passing satellite. But when the same phenomenon occurred again 3 weeks later, same duration, same intensity, the hunt for answers began in earnest. Asteroids simply don't behave this way. They're cold, inert lumps of rock and metal, not cosmic light sources. The leading natural explanation pointed to triboluminescence, a rare phenomenon where certain minerals emit light when fractured or crushed. On Earth, this can be seen in substances like quartz or sugar crystals when they're ground together in the dark. Could this asteroid's interior be rich in similar minerals, glowing briefly as internal stresses cracked its surface? The math didn't quite add up. Triboluminescence requires mechanical energy, something to cause the fractures, yet telescopes detected no collisions, no shifts in the asteroid's spin, nothing that would explain sudden, violent stress. That's when attention turned to external triggers. Some researchers proposed an invisible cosmic particle beam, perhaps from a distant neutron star or black hole, striking the asteroid's surface and energizing its minerals. Others wondered if concentrated solar wind, funneled by a freak magnetic anomaly, could have acted like a natural blowtorch, supercharging the rock's outermost layer. But the most unsettling theory came from a small team studying exotic matter. They noted that the light spectral signature bore an eerie resemblance to certain lab-generated plasmas, the kind produced in experiments with portable fusion reactors. Could the asteroid contain materials with unstable atomic structures, briefly igniting under the right conditions? It wasn't just speculative. Deep scans revealed trace elements in the asteroid's composition that, when theoretically combined, might produce such an effect. The catch: those elements don't naturally occur together. Their presence in the same rock defied known geologic processes, raising the unnerving question: was this asteroid's light a freak accident of chemistry or a sign of something altered? Skeptics, as always, pushed back. Nature is full of poorly understood phenomena, and jumping to conclusions about alien engineering helps no one. Yet even they couldn't dismiss the eerie timing. The light pulses weren't random. They followed a loose but detectable pattern, clustering around periods when the asteroid passed through a specific region of Earth's magnetic tail. Coincidence? Possibly, but when the same object does something impossible on schedule, it's hard not to wonder if we're missing a piece of the puzzle. Whether it's a natural oddity or something stranger, this luminous asteroid forces us to confront how little we truly know about the cosmos. Most of the universe's mysteries don't announce themselves with blazing signals or crashing impacts. Sometimes they just flicker in the dark, brief, quiet, and gone before we can even ask the right questions. And if a single unassuming rock can rewrite the rules of light, what else is out there waiting to illuminate the shadows of our understanding? What if some of these interstellar anomalies aren't just cosmic accidents but deliberate messages, carefully packaged inside speeding space rocks? The message in a bottle theory suggests that advanced civilizations might use asteroids as interstellar couriers, embedding signals or even data within their structures. Unlike radio transmissions, which fade over distance, an asteroid's journey could span millennia, preserving its contents intact until it's found. Consider how we might detect such a message. Scientists would start by scanning for unnatural patterns, repeating radio bursts synchronized with the asteroid's rotation, or mineral compositions arranged in precise geometric layers. Some researchers propose that a message might be encoded in the asteroid's very rotation, using slight, artificial variations in spin as a kind of cosmic Morse code. Others speculate about nanoscale engravings in the rock's surface, readable only with high-powered microscopes containing schematics, mathematical constants, or even biological blueprints. The implications are staggering. If even one of these asteroids carries intentional information, it would mean we're not just discovering natural phenomena, we're intercepting mail from a civilization that could be long gone. The idea isn't as far-fetched as it sounds. Humans have already sent physical messages into space, like the gold-plated records aboard Voyager, etched with sounds and images of Earth. An advanced society might take this concept further, engineering asteroids as self-contained time capsules designed to survive the harshness of space. Yet skepticism remains. Nature is a master of mimicry, and what looks like a coded signal could just be a quirk of physics we haven't unraveled. The challenge lies in distinguishing design from coincidence, a task that requires more than just curiosity but entirely new tools. Future missions might need to sample these asteroids directly, drilling into their surfaces or deploying AI to analyze their structures atom by atom. Whether it's a hopeful fantasy or a genuine possibility, the message in a bottle theory forces us to rethink our place in the universe. If the cosmos is full of hidden letters waiting to be opened, what might they say, and are we ready to read them? Deep in the asteroid belt, a small, unremarkable-looking rock was quietly rewriting the rules of cosmic chemistry. When scientists first analyzed the composition of asteroid DH215, they expected the usual mix of silicates, metals, and carbon compounds found in most space rocks. Instead, they got a shock. The asteroid's surface was laced with molecular combinations that shouldn't exist, not just rare, but entirely undocumented in nature. The patterns defied all known geological and astrophysical processes, sparking a debate that cut to the heart of how we understand the universe. What made this asteroid's chemistry so bizarre? For starters, it contained tightly bonded clusters of iridium and osmium metals that almost never occur together in nature without extreme human intervention. These elements typically require industrial-scale refinement to combine, like in the production of high-performance alloys for spacecraft or medical implants. Yet here they were, fused seamlessly in a rock that had presumably drifted through space for billions of years. Even more puzzling were the carbon structures woven through the metals, not simple graphite or diamond, but intricate lattices resembling synthetic nanomaterials engineered in labs. One researcher described it as finding a microchip embedded in a piece of limestone. The scientific community split into two camps. The first insisted there had to be a natural explanation, however unprecedented. They pointed to the extreme environments near neutron stars or black holes, where pressures and temperatures could theoretically forge exotic materials we've never observed. Maybe DH215 was a shard from such a cosmic forge, ejected across interstellar space by some ancient cataclysm. The second camp, far more controversial, dared to ask the unthinkable: could these structures be evidence of engineering? The asteroid's chemical fingerprints bore an uncanny resemblance to advanced human-made materials, like the heat shields on re-entry vehicles or the ultra-hard coatings used in cutting-edge nanotechnology. If another civilization had developed similar or superior technology, might this be a discarded fragment of their work? Skeptics countered that nature is endlessly inventive, and human bias often leads us to see design where none exists. After all, the first synthetic quasicrystals were discovered in meteorites after humans created them, proving nature could stumble upon complex atomic arrangements on its own. But the skeptics struggled to explain one glaring oddity. DH215's chemical layers weren't randomly distributed. They formed concentric rings like tree rings, with each layer representing a different, but equally improbable material profile. Natural stratification in asteroids usually follows the chaotic mixing of impacts and heating events. This looked methodical, almost curated, the most chilling possibility. DH215 might be a fragment of something much larger, a shattered probe, a derelict vessel, or even a targeted delivery system. Some theorists suggested the asteroid could be a kind of seed, deliberately engineered to disperse advanced materials across star systems as a form of cosmic contamination or even a slow-burning message. Others proposed it was simply space junk on an interstellar scale, debris from a long-dead civilization's experiments. Whatever the truth, this unassuming rock forces us to confront a humbling gap in our knowledge. The universe's periodic table might be far more extensive and far stranger than we ever imagined. And if even a single asteroid can carry chemistry that defies all our models, what else is drifting out there, waiting to upend our understanding of what's possible? In the silent depths of space, few things unsettle astronomers more than an object that refuses to stay quiet, especially when it starts pulsing like a heartbeat. That's exactly what happened when researchers discovered an asteroid emitting bursts of energy with clockwork precision, every 11 hours and 23 minutes, like cosmic metronome. At first glance, it seemed like just another rogue rock tumbling through the solar system. But when telescopes picked up rhythmic flashes of radio waves and infrared radiation, the scientific community snapped to attention. Nature thrives on chaos, so what could possibly explain such unnatural regularity? The leading theory points to an obscure phenomenon called rotational bursting. Some asteroids, when spun up by solar radiation or gravitational nudges, can develop internal stress fractures. As they rotate, these cracks open and close like hungry mouths, releasing built-up thermal energy in predictable bursts. It's a rare process, but not impossible, except this asteroid's pulses were too clean, too evenly spaced. Computer models showed natural fracturing should produce slight variations in timing, like a skipping record. These pulses, by contrast, were flawless, as if engineered by Swiss watchmakers. Then came the real curveball. Spectral analysis revealed metallic veins running through the asteroid's core. Not the usual iron-nickel blend, but a highly conductive alloy resembling something you'd find in satellite components. When exposed to solar wind, these veins could theoretically act like antennae, converting plasma interactions into radio emissions. But here's the kicker. The asteroid's composition suggested these metals weren't just mixed in, they were aligned, forming geometric patterns that amplified signals in specific directions. One researcher described it as finding a radio tower buried inside Mount Everest. Skeptics countered that pulsars, rapidly spinning neutron stars, also emit regular bursts without artificial help. Could this be a scaled-down version of that process? Yet pulsars operate on entirely different physics, their rhythms driven by unimaginably dense matter. An ordinary asteroid shouldn't have the mass or magnetic field to mimic that behavior, unless, of course, it wasn't ordinary at all. The most provocative theory emerged from a team studying ancient astronaut hypotheses. They noted that the pulse intervals matched prime-numbered sequences, a pattern often proposed as a potential universal hello in interstellar communication. If an advanced civilization wanted to mark certain asteroids as navigation beacons, embedding pulse transmitters would be an efficient way to ensure visibility across light years. The idea was dismissed as fringe, but even critics admitted the timing was unsettling. Whether it's a quirk of geology or something more profound, this pulsing asteroid challenges our assumptions about what's possible in the quiet corners of space. After all, the universe doesn't waste precision. When something in the void starts ticking like a clock, it's worth asking who or what wound it up. Among the countless asteroids drifting through space, one stood out not for its size or composition, but for its utter defiance of gravity itself. Designated GX-117, this rogue rock behaved like it had a mind of its own, executing maneuvers that sent astrophysicists scrambling for their whiteboards. At first, its odd trajectory was dismissed as a miscalculation, perhaps a mislabeled comet venting unseen gases. But when repeated observations confirmed the impossible, the scientific community had to confront a chilling reality. This asteroid wasn't just moving under the influence of gravity. It was fighting it. The anomaly became undeniable when GX-117 performed what could only be described as a gravitational pirouette. Instead of following the smooth, predictable arc dictated by the sun's pull, it made a series of minute but precise adjustments, slowing down, speeding up, even altering its angle of approach as if guided by an invisible hand. The deviations were subtle, but the math was unambiguous. Something other than natural forces was influencing its path. Theories erupted like cosmic fireworks. The most conservative explanation proposed hidden mass may be a dense core of exotic matter buried beneath the asteroid's surface, warping spacetime around it like a miniature black hole. Others pointed to the Yarkovsky effect, where uneven heating from sunlight can nudge asteroids off course over time. But neither theory could account for the instantaneous nature of GX-117's movements. Gravity and thermal drift don't work on demand, they're slow, relentless processes. This was more like a driver adjusting the steering wheel in real time. That's when the whispers of advanced propulsion began. A handful of researchers dared to suggest the unthinkable. Could GX-117 be equipped with some form of technology? Humanity has already experimented with ion drives and solar sails. What if another civilization had refined these concepts into something far more sophisticated? The idea wasn't entirely science fiction. Theoretical physics allows for concepts like warp drives or gravitational manipulators, though we lack the engineering to build them. If an advanced species had cracked the code, perhaps they'd use asteroids as discrete test beds, disguising their experiments as natural phenomena. Skeptics, of course, demanded a simpler answer. They proposed that GX-117 might be caught in a gravitational slingshot with an unseen object, a small black hole, a rogue planet, or even a dense dust cloud. Yet scans revealed no hidden masses nearby, no distortions in the fabric of space that could explain the behavior. The asteroid seemed to exist in a gravitational anomaly of its own making. The most unsettling possibility, GX-117 might not be alone. Archival data revealed at least 2 other asteroids with similarly unnatural trajectories, all clustered in the same region of the solar system. Were these flukes or evidence of something systematic? If nature couldn't explain the patterns, what did that leave? Whether it's an undiscovered law of physics or something far more profound, GX-117 forces us to confront the limits of our understanding. The universe, it seems, still holds cards it hasn't shown us. And if an asteroid can rewrite the rules of gravity, what other cosmic constants might just be? Suggestions. Among the countless space rocks tumbling through the void, one asteroid stands out like a diamond in the coal, its surface so unnaturally reflective that astronomers first mistook it for a discarded satellite. Dubbed the Mirror Asteroid, this cosmic oddity doesn't just reflect sunlight, it amplifies it, bouncing back nearly 95% of the light that strikes it, a figure that shatters all known records for natural celestial bodies. For context, most asteroids reflect less than 20%, their surfaces weathered by eons of cosmic radiation and micrometeorite impacts. This one, it gleams like it was just polished. At first, scientists assumed they were seeing an icy fragment, perhaps a wandering piece of a shattered comet's nucleus. Ice can be highly reflective, but the asteroid's spectral signature told a different story. Instead of water or methane ice, its surface was dominated by an ultra-smooth metallic alloy, laced with elements like rhodium and palladium, materials so rare in nature that they're often mined for Earth's most expensive jewelry. The odds of these metals forming a naturally occurring mirror in space are astronomically low, like finding a Fabergé egg in a landfill. Theories quickly polarized. One camp insisted on a natural, if bizarre, explanation. They pointed to Mercury's polar ice caps, where volatile metals condense in permanently shadowed craters, creating strange reflective patches. Could this asteroid have formed near a star with extreme temperature swings, allowing metals to vaporize and settle into glassy, mirror-like sheets? Others countered that Mercury's reflections are patchy and uneven, nothing like the asteroid's flawless, continent-spanning sheen. Then came the provocative questions. What if this wasn't an accident of nature? Human technology already uses reflective surfaces in space. Think of the laser geodynamic satellites, or LAGEOs, which are covered in corner cube mirrors to precisely measure Earth's rotation. An advanced civilization might deploy similar arrays as navigation beacons or even as part of a solar energy collection system. the asteroid's shape only fueled speculation. Slightly flattened with edges that suggested intentional symmetry, it looked less like a random rock and more like a discarded segment of some colossal parabolic dish. The real twist came when astronomers noticed something eerie. The mirror asteroid's reflectivity wasn't constant. During specific alignments with Earth, its brightness would surge, as if tilting to flash signals in our direction. Natural surfaces don't aim, yet the timing of these flashes followed no discernible pattern, leaving scientists torn between two unsettling possibilities. Either they were witnessing a natural phenomenon so rare it had never been documented before, or they were staring into what might be the most sophisticated cosmic hello in history. Skeptics argue that nature is full of optical illusions, and human bias sees design where none exists. But when an object in the void behaves like it's trying to be seen, it's hard to look away. Whether it's a cosmic accident or a message in plain sight, the mirror asteroid forces us to confront a simple truth sometimes. The universe doesn't just hide its secrets. Sometimes it holds them up to the light, waiting for us to notice. In 1996, humanity took a bold step into the cosmic unknown, not with a spacecraft but with a simple radio signal. Scientists at the Evpatoria radar telescope in Crimea beamed a message toward a distant star system, a digital hello encoded in binary pulses. Nearly 2 decades later, something remarkable happened. An interstellar asteroid passing through our solar system appeared to respond. At first, no one made the connection. The asteroid, later designated CT-139, seemed utterly ordinary, a dim, fast-moving speck among thousands. But when researchers at the Allen Telescope Array reviewed old radio data, they noticed an anomaly. Exactly 48 hours after the Evpatoria transmission would have reached CT-139's projected origin point, the asteroid emitted a brief but unmistakable radio burst. Not random static, but a pulse sequence eerily similar to the original signal, almost like an echo. The timing was too precise to dismiss as coincidence. Skeptics immediately pounced. Space is full of radio noise. They argued solar flares, pulsar emissions, even interference from earthly satellites. The response could have been any of these. But the data told a stranger story. The asteroid's burst wasn't just similar in timing. Its frequency and modulation mirrored the human transmission, with key mathematical sequences intact. It was as if someone had taken our message, stripped out the content, and bounced back the structural framework. Then came the real twist. When astronomers analyzed CT-139's composition, they found traces of materials unusually adept at reflecting radio waves, metallic veins with crystalline structures that could, in theory, act as natural antennas. If the asteroid had passed through a dense cloud of ionized gas at just the right angle, perhaps these veins briefly resonated with the incoming signal, creating a distorted but detectable reply. Critics countered that no known natural process could produce such a targeted echo. Cloud interactions scatter signals chaotically. They don't meticulously preserve timing and structure. That left 2 possibilities. Either we'd stumbled upon a previously unknown astrophysical phenomenon, one that, against all odds, mimicked communication, or CT-139 wasn't entirely natural. The debate still simmers today. No follow-up signals have been detected, and the asteroid itself has long since vanished into the void. But its legacy lingers as a haunting question. Did we, for one fleeting moment, tap on the universe's window and hear something tap back? Astronomers have grown accustomed to tracking thousands of asteroids with pinpoint precision. So when one vanishes without a trace, it sends shockwaves through the scientific community. That's exactly what happened with Signal 19, an unassuming space rock catalogued as J029Nef, which didn't just drift out of view or disintegrate in a fiery breakup. One day it was there, cruising along its predicted path, the next gone, not dimmed, not obscured by cosmic dust, utterly erased from existence, as if someone had flipped a celestial light switch. The strangest part, this wasn't a case of human error or telescope malfunction. Multiple observatories had been tracking J029 NEF for weeks, logging its position, speed, and rotation with meticulous accuracy. Then, during a routine observation window, the asteroid simply stopped reflecting light. No explosion, no debris field, no gradual fade. One moment, telescopes captured its faint but steady silhouette against the starfield. The next, the coordinates were empty. It didn't even leave behind the telltale infrared signature of a collision, just pure, unbroken darkness where an object should have been. Theories ricocheted between the mundane and the extraordinary. The simplest explanation, the asteroid might have been a loosely packed rubble pile, a cluster of rocks held together by weak gravity. If it spun too fast, centrifugal force could have torn it apart silently, scattering its fragments too thinly to detect. But even then, astronomers should have spotted something, dust clouds, a faint debris trail, some kind of aftermath. Instead, the void remained stubbornly blank. Then came the wilder ideas. Could J029 NEF have been something other than an asteroid? Some researchers floated the possibility of an ultra-thin, lightweight structure, perhaps a discarded solar sail or defunct probe, that had been misclassified as a natural object. If it altered its orientation or deployed some kind of stealth coating, it might have effectively disappeared from optical telescopes. Others whispered about exotic materials, theoretical metamaterials that bend light around an object, rendering it invisible, or even speculative technology capable of manipulating space-time to cloak itself. But the most unsettling hypothesis came from an outlier group studying cosmic camouflage. They noted that certain microorganisms on Earth, like glass squid or deep-sea crustaceans, can manipulate their own transparency to evade predators. What if an interstellar object had evolved or been designed to do the same? The idea sounded like science fiction until astronomers realized J029 NEF had exhibited subtle, anomalous brightness fluctuations in the days before its disappearance, almost like it was testing its reflectivity. Of course, skeptics dismissed this as confirmation bias, humans seeing patterns where none exist. Yet the mystery remains, whether it was a cosmic fluke, a stealthy artificial object, or something beyond our current physics. J029 NEF's vanishing act forces us to confront a humbling truth. The universe might be hiding things in plain sight. And sometimes the most profound discoveries aren't what we find, but what we lose without a trace. The universe has a way of throwing curveballs, but nothing prepared astronomers for Signal 20, an asteroid that didn't just follow the rules of gravity, it seemed to rewrite them. Designated K794, this interstellar visitor should have sailed through our solar system on a predictable, elliptical path. Instead, it did the cosmic equivalent of a sudden U-turn, altering its trajectory in a way that defied every known law of celestial mechanics. One moment it was coasting toward the outer planets, the next it veered sharply as if tugged by an invisible hand. The change wasn't gradual, it was abrupt, precise, and utterly inexplicable. At first, scientists scrambled for natural explanations. The leading theory pointed to a gravitational slingshot. Perhaps the asteroid had passed too close to an unseen object, like a rogue planet or a dense patch of dark matter bending its path. But scans of the region revealed nothing. No hidden masses, no debris clouds, not even a whisper of gravitational distortion. Another hypothesis suggested outgassing hidden jets of vaporized ice nudging the asteroid off course. Yet K794 showed no signs of sublimation, no telltale glow of venting gases. It was as if the rock had simply decided to change direction. Then came the data that sent chills down spines. Detailed tracking revealed the trajectory shift wasn't just sudden, it was efficient. The asteroid's new path conserved an unnatural amount of energy, like a spaceship executing a perfect orbital burn. Natural forces are messy, they leave drag, turbulence, wasted motion. This adjustment was sleek, almost optimized. That's when whispers of artificial control began. Could K794 be equipped with some form of propulsion? Humanity's own probes use gravity assists and thruster adjustments to fine-tune their paths. If another civilization had advanced propulsion, perhaps light sails, ion drives, or something beyond our physics, might they disguise their craft as innocuous asteroids? Skeptics pushed back hard. They proposed exotic but natural phenomena. Maybe K794 had collided with a micro-black hole, one too small to detect but massive enough to alter its course. Or perhaps it was a fragment of a neutron star, carrying bizarre magnetic properties that interacted unpredictably with the solar wind. These ideas stretched the limits of credibility, but so did the alternative, that we were witnessing something designed. The debate took a darker turn when researchers uncovered archival records. K794 wasn't the first asteroid to behave this way. At least 3 others in the past century had exhibited similar, though less dramatic, deviations. All shared eerie commonalities. Their course changes occurred near the ecliptic plane, the highway of the solar system where gravitational assists would be most effective. Coincidence or evidence of a pattern, whether it's an undiscovered law of physics or something far more intentional, K794 forces us to confront an uncomfortable truth. The cosmos might be playing a game we don't yet understand. And if asteroids can change direction on a whim, what else in the void might not be what it seems? Somewhere in the depths of the asteroid belt, an object lurks that defies one of space's most basic rules: temperature. Designated Signal 21, this interstellar oddity appeared at first glance to be just another frozen relic of the early solar system, its surface registering a bone-chilling -200 degrees Celsius. But then, without warning, it did the impossible. It heated up, not gradually, not in response to sunlight, but in sudden, violent spikes that sent thermal scanners haywire. For exactly 17 minutes at a time, entire sections of the asteroid would surge to nearly 80 degrees hotter than a summer day on Earth before plunging back into cryogenic silence. At first, astronomers assumed their instruments were glitching. Asteroids simply don't behave this way. They're passive, inert chunks of rock and metal, absorbing and radiating heat predictably as they rotate in and out of sunlight. But Signal 21's heat spikes followed no such rhythm. They erupted at random intervals, sometimes weeks apart, sometimes mere hours, with no apparent trigger. The bursts weren't localized. Either thermal maps showed heat radiating from inside the asteroid, as if some hidden furnace were flickering to life beneath its icy crust. Theories erupted like solar flares. The most conservative explanation pointed to radionuclides, unstable elements like uranium or thorium decaying deep within the asteroid's core, releasing heat in sporadic pulses. But the math refused to cooperate. Natural radioactive decay produces steady warmth, not the sudden, searing spikes observed here. Others proposed tidal heating. Perhaps the asteroid's irregular shape caused it to flex gravitationally as it passed near planets, generating internal friction. Yet Signal 21's heat events occurred even in the empty void between orbits, far from any gravitational influence. Then came the wild card: external triggers. A small but vocal group of researchers noticed something eerie. The heat spikes often coincided with bursts of solar activity. Not the gentle ebb and flow of solar wind, but violent coronal mass ejections, the sun's most explosive tantrums. Could charged particles from these eruptions be interacting with the asteroid in some unknown way? Laboratory experiments revealed that certain metallic alloys, when bombarded by high-energy plasma, can briefly superheat due to quantum tunneling effects. If Signal 21's core contained such exotic materials, it might act like a cosmic battery, storing and abruptly releasing solar energy in bursts. Skeptics countered that no known asteroid composition could amplify energy so dramatically. Unless, of course, the asteroid wasn't entirely natural. One radical paper suggested Signal 21 might harbor dormant technology, a relic heat exchanger or power supply from some ancient civilization, accidentally reactivated by passing radiation. The idea wasn't entirely sci-fi. Human space probes like Voyager still carry functional nuclear batteries after decades in the void. If another species had ever littered the cosmos with similar devices, might their derelict machinery still flicker on when conditions align? The most unsettling possibility, Signal 21 might not be unique. Deep archival searches revealed at least 2 other asteroids with similar thermal anomalies, all clustering in the same quadrant of the belt. Were these natural flukes or evidence of something systematic? The universe rarely repeats accidents so precisely. Whether it's a freak of physics or a whisper from something beyond our understanding, Signal 21 forces us to confront a humbling truth. Even the coldest corners of space might be hiding fires we don't yet know how to read. And if an asteroid can switch from icebox to oven in moments, what other thermodynamic rules might be waiting to shatter? Among the countless space rocks drifting through the cosmos, none has sparked the human imagination quite like Signal 22, an asteroid that appears to stare back at us with an uncannily familiar face. When high-resolution images from the European Space Agency's Gaia mission first revealed its surface, the Internet erupted. There, etched into the asteroid's rugged terrain, were 2 shadowed depressions resembling eye sockets, a ridge like a nose, and even a faint, curved fissure that looked unsettlingly like a mouth. The resemblance to a human face wasn't just striking, it was eerie. But was this a trick of light and perspective, or something far stranger? Pareidolia, the brain's tendency to find familiar patterns in randomness, is the most obvious explanation. We see faces everywhere, in clouds, mountain ranges, even burnt toast. Mars's infamous face on Mars, later revealed to be a trick of shadows, proves how convincingly geology can mimic art. Yet Signal 22's features push the boundaries of coincidence. Unlike the Martian face, which required low-resolution images and specific lighting to appear humanoid, this asteroid's markings remain recognizable across multiple angles and lighting conditions. Their eyes, for instance, aren't random pits, they're nearly symmetrical, aligned along a central axis with depths that consistently cast shadows resembling pupils. Even the mouth curves in a way that mirrors natural facial expressions, neither too perfect to seem artificial nor too messy to dismiss as chaos. Scientists immediately scrambled for natural explanations. Could wind erosion or ancient volcanic activity have sculpted these features? Unlikely. Asteroids lack atmospheres for wind, and their small size rarely supports volcanic forces. Impact craters were the next suspect, but craters tend to be circular, not elongated or angular like facial features. Then came the wild card, tidal forces. If Signal 22 had once orbited close to a gas giant, gravitational stretching might have fractured its surface in unusual ways. But why would those fractures converge into such a disturbingly coherent pattern? The debate took a speculative turn when independent researchers noticed something even weirder. The face wasn't alone. Thermal scans revealed that the eye sockets retained heat differently than the surrounding rock, as if their composition varied. Spectroscopy later confirmed it. The eyes were rich in materials like olivine and magnetite, minerals that absorb and radiate heat unusually well. This wasn't just a shape, it was a structure with distinct physical properties. Skeptics argue that nature abhors symmetry but doesn't forbid it entirely. Crystal formations, beehives, even galaxies exhibit precise geometries without intelligent design. Yet the odds of random processes creating a near-perfect facial simulacrum complete with thermally distinct eyes on a lone asteroid are vanishingly small. That's where the fringes of science weighed in. Could Signal 22 be a monument, a marker, or even a warning from some long-gone civilization? ancient cultures on Earth built colossal faces to honor gods and rulers, might an advanced species have done the same on a cosmic scale? Or perhaps the truth lies somewhere between. The universe is vast enough for freak accidents to feel intentional. Signal 22 might be the ultimate Rorschach test, a blank slate onto which we project our hopes, fears, and curiosities. But whether it's a trick of the mind or a message in the stone, one thing's certain: this asteroid doesn't just orbit the sun. It orbits our imagination, daring us to ask, when we stare into the void, what stares back. Somewhere in the vast emptiness between Mars and Jupiter, an asteroid began speaking in hushed tones, not with the booming pulses of fast radio bursts or the rhythmic beats of a cosmic metronome, but with faint, whispering vibrations that seemed to flutter at the very edge of detection. Designated Signal 23, this unassuming rock didn't announce itself with fireworks. Instead, it murmured, emitting delicate oscillations so subtle that researchers initially dismissed them as equipment noise. But when the whispers persisted, soft, irregular, yet undeniably patterned, the scientific community leaned in, straining to decipher what the cosmos was trying to say. These weren't the usual cracks and groans of an asteroid adjusting to temperature shifts or gravitational stress. Most space rocks emit low-frequency rumbles when fractured or heated, akin to the creaking of an old wooden ship. Signal 23's vibrations, however, clustered in a narrow band just above infrasound, skimming the lower threshold of human hearing. If translated into sound, they might resemble a chorus of rustling leaves or distant wind chimes, hauntingly organic in a realm where silence reigns. The patterns defied simple explanation. Some sequences repeated at irregular intervals, while others flared unpredictably, as if responding to unseen stimuli. The search for a natural cause led scientists down twisting paths. One hypothesis pointed to seismic whispering, a rare phenomenon where micrometeorite impacts or internal collapses send delicate tremors through an asteroid's core. Earth's moon experiences similar moonquakes, but those events are sporadic and chaotic. Signal 23's vibrations, by contrast, carried an eerie coherence, like a tuning fork struck gently but insistently. Others theorized electrostatic discharges, tiny sparks jumping between dust grains on the asteroid's surface, generating vibrations as they ionized the thin exosphere around it. Yet lab simulations failed to replicate the whisper's peculiar cadence. Then came the revelation that set pulses racing, the vibrations occasionally aligned with solar flares. When particularly violent eruptions burst from the sun, Signal 23's whispers often intensified or shifted frequency within hours, as if reacting. This wasn't just passive resonance, it hinted at a dynamic interplay between the asteroid and its environment. Could its surface be laced with piezoelectric materials, crystals that convert mechanical stress into electrical energy, and vice versa? On Earth, quartz watchers exploit this very principle. If Signal 23 contained vast deposits of similar minerals, solar wind might be playing them like a bow on a violin string. Skeptics urged caution, pointing out that correlation isn't causation. Space is a symphony of electromagnetic noise, and finding apparent patterns is inevitable. But the whispers grew harder to dismiss when researchers noticed something even stranger. Brief moments where the vibrations seemed to mirror each other in inverted sequences, like a call and response. Natural echoes don't reverse polarity so precisely. The findings sparked whispers of another kind, quiet debates in conference halls and observatory break rooms. Could this be evidence of something more than geology? The most tantalizing theory came from a linguist-turned-astrobiologist who noted that the asteroid's patterns loosely fit something called the Zipf distribution, a statistical hallmark of human language and other complex communication systems. In nature, random noise distributes unevenly. Structured information tends to cluster in specific ways. Signal 23's whispers, while far from linguistic, bore faint mathematical fingerprints of organization. It wasn't proof of intent, but it was enough to raise the question. If a civilization did want to send a subtle, long-term signal, might they embed it in the vibrations of an asteroid, ensuring it endured across millennia? Of course, the universe thrives on ambiguity. For every argument that these whispers carried meaning, another countered with Occam's razor. The simplest explanation, unknown geology, is usually correct. Yet Signal 23 lingers as a paradox, a riddle wrapped in cosmic static. Whether it's the gentle sigh of natural forces or the faintest murmur of something beyond our understanding, one truth remains: sometimes the universe doesn't shout. It leans close and breathes. Deep in the asteroid belt, drifting silently between Mars and Jupiter, lies an object that shouldn't exist, at least not by our current understanding of the cosmos. Signal 24, catalogued as BZ509, isn't just unusual, it's an outright rebel against the periodic table. When astronomers first analyzed its spectral signature, their instruments practically short-circuited with confusion. Every known asteroid in our solar system fits into broad categories: carbon-rich, silicate-heavy, or metallic. But this one, its chemical fingerprint matched nothing in our databases, not just rare but entirely undocumented. The initial scans read like a cosmic prank. Instead of the usual iron, nickel, or silicon oxides, BZ509's surface was dominated by a bizarre cocktail of elements: ytterbium, lutetium, even traces of promethium materials so rare on Earth they're often mined in quantities smaller than a grain of sand. But here they were, fused together in ratios that defied all known geological processes. It was as if someone had taken the periodic table, thrown it in a blender, and poured out a concoction that shouldn't be stable yet somehow was. Theories ricocheted between the plausible and the extraordinary. One camp argued for extreme stellar origins. Perhaps this asteroid was a shard from a neutron star collision, where unfathomable pressures and temperatures forge elements in ways we've never observed. Others pointed to exotic supernova, the kind that seed galaxies with our process elements heavier than uranium. But even these cosmic forges couldn't explain the asteroid's most baffling feature: its layered structure. Core samples inferred from radar revealed concentric rings of alternating conductivity, like an onion woven from alternating sheets of insulator and superconductor. Nature doesn't build that way, not without help. That's when whispers of alien alloy began. A handful of researchers noted unsettling parallels between BZ509's composition and theoretical metamaterials, engineered substances designed to manipulate light, heat, or even gravity in ways natural matter can't. Human labs are just beginning to dabble in such materials. Imagine what a civilization 1,000 years ahead of us might create. Could this be a fragment of some long-dead society's technology, drifting through space like a message in a bottle? Skeptics, of course, countered with Occam's razor. The universe is vast, they argued, and we've barely scratched the surface of its chemical diversity. Just because we haven't seen something before doesn't mean it's artificial. Yet even they struggled to reconcile one glaring anomaly: BZ509's orbit. Unlike most asteroids, which cluster in families with similar trajectories, this loner followed a path untethered to any known group, a rogue traveler with no apparent origin point. The most chilling possibility: we might be looking at a piece of something bigger. Some theorists suggest BZ509 could be debris from an exoplanet so alien, its very geology operated on different rules. Imagine a world where uranium is as common as aluminum, or where mountains are capped with metallic snow. If such places exist, their shattered remnants might explain the impossible chemistry we're witnessing. Whether it's a cosmic fluke or a relic of something beyond our comprehension, Signal 24 forces a humbling admission. The universe's recipe book has pages we haven't even glimpsed yet. And if a single asteroid can upend our understanding of matter itself, what other elemental surprises might be lurking in the dark? What if the most profound message from the stars isn't a radio transmission or a laser beam, but a rock? Signal 25, the so-called final message asteroid, takes the mystery of interstellar objects to a chilling new level. Unlike the pulsing beacons or unnatural orbits of other cosmic anomalies, this one doesn't shout for attention. It hides in plain sight, its secrets locked not in signals or behavior, but in its very substance. When scientists cracked open its spectral data, they found something that defied both geology and logic. Isotopic ratios so precise, so mathematically elegant, they couldn't be accidental. The discovery began with a routine scan. As astronomers mapped the asteroid's composition, they noticed its oxygen isotopes aligned in a ratio of exactly 1:2:4, a perfect harmonic series found nowhere else in nature. Isotopes, the atomic variations of elements, usually scatter randomly based on cosmic conditions. But here, they were arranged like notes in a scale, as if composed rather than formed. Digging deeper, researchers uncovered more bizarre patterns. Layers of iridium and tungsten deposited in Fibonacci-like spirals, and crystalline structures with angles matching sacred geometries from ancient Earth cultures. The odds of these features arising naturally, astronomers calculated them at less than 1 in several trillion. This is where the final message theory takes shape. Imagine a civilization facing extinction, with no hope of survival but desperate to leave a record of its existence. Radio signals fade over light years and monuments crumble, but an asteroid, drifting through space for billions of years, virtually indestructible, it could serve as the ultimate time capsule. By engineering its atomic structure, a species might encode information in the very fabric of matter, creating a message that outlasts stars. The isotopic ratios could be a universal hello, the geometric layers a primer on their mathematics, and the crystals a map pointing to their origin. Critics argue that nature is capable of astonishing coincidences, and human bias sees design where none exists. They point to quasi-crystals once thought impossible in nature until we found them in meteorites. Yet even skeptics pause at the asteroid's most unsettling quirk, its trajectory. Unlike most interstellar visitors which zip through the solar system on random paths, Signal 25's orbit brings it within gravitational reach of Earth every 12,000 years, a timescale eerily reminiscent of humanity's cyclical rise and fall of civilizations. If this is a message, it wasn't just meant for anyone. It was meant for us, time to arrive when a species might finally be ready to read it. The philosophical weight of this idea is staggering. If true, we're not just studying a space rock, we're holding a fossilized whisper from a species that gazed at their night sky, just as we do, and chose to etch their story into the bones of the cosmos. It forces us to confront the fragility of intelligence in an indifferent universe, and the audacity of hope that drives beings to scream "we were here" into the void. Whether Signal 25 is a cosmic fluke or a deliberate masterpiece, its silent presence asks the most haunting question of all. If the universe is full of such messages, how many have we already missed, and how many more are still drifting unread in the dark? From Oumuamua's impossible acceleration to the eerie whispers of Signal 23, these 25 interstellar enigmas aren't just curiosities, they're cosmic cracks in the foundation of everything we thought we knew. Each one defies explanation in its own way. Asteroids that vanish without a trace, rocks pulsing like lighthouses, and signals so precise they feel like a hand reaching out from the void. Together, they paint a picture of a universe far stranger, far more alive with mystery than our textbooks ever dared to suggest. What makes these anomalies so thrilling isn't just their strangeness, it's the way they force us to question the boundaries of science itself. Are we witnessing undiscovered physics, the remnants of ancient technologies, or something beyond even our wildest theories? The truth is, we don't know yet. And that's the beauty of it. Every unexplained signal, every rogue asteroid is an invitation, a challenge to look deeper, think bigger, and stay curious. So what do you think is out there? Have we been intercepting cosmic mail from civilizations long gone? Or are these just the universe's way of reminding us how much we still have to learn? Drop your wildest theories in the comments, because the greatest discoveries often start with a single bold idea. And if you're hungry for more mysteries, hit subscribe. The cosmos isn't done surprising us yet, and neither are we. The next revelation, it's already out there waiting. Let's find it together.